Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be looking at how you transform trigonometric graphs. First of all, a few reminders. So transformations and graphs, we're not really learning anything new in this lesson. We've already learned about translations, that y equals f of x plus a, where you add on a to the whole function, moves the graph of f of x upwards by a units. If you add on a to the x value, so f of x plus a, that'll move the graph of f of x left by a units. It's worth remembering, whenever you adjust the whole function, what you would expect to happen does happen. When you adjust the x value, the opposite to what you would expect happens. So when we add a to the x values, the function actually moves left by a units. We've learned about stretches. A f of x stretches the graph of f of x vertically with a scale factor of a. F of ax stretches the graph of f of x horizontally, but with scale factor 1 over a. So if that was 2x, then everything would move into half x, half the size. And reflections. Y equals minus f of x reflects the graph of f of x in the x-axis, and f of minus x reflects the graph of f of x in the y-axis. And the other thing that we learned in the last lesson is just how to make a very quick sketch of a trig function. You need to remember the general shape of the curve, the value of the function at x equals 0, that sine and cos both have a maximum and minimum of plus and minus 1. A significant point is reached with sine, cos, and tan every 90 degrees, that sine and cos repeat every 360, and the tangent repeats every 180 degrees. Okay, remembering all of that, have a go at example 1. So for x in the range minus 360 to plus 360, try and sketch the following graphs. First of all, sine x, then 1 plus sine x, and then the other questions. So have a go at this, pause the video, and then come back to me again when you're ready. Okay, let's go through these 7 graphs. So first of all, y equals sine x. Well, y equals sine x has that shape. It starts at 0, repeats every 360, something happens every 90 degrees. Y equals 1 plus sine x. Well, in general, if you add a to the function, it moves the graph of f of x upwards by a units. So if we add on 1 to sine x, then the graph of sine x will move upwards by 1 unit. So it would move up to here, where the minimum would now be at 0 and the maximums would be at 2. Y equals the sine of x plus 90 degrees. Well, in general, f of x plus a moves the graph of f of x left by a units. So the sine of x plus 90 will move the graph of sine x left by 90 degrees. So the whole graph will shift left by 90 over to there. Question 4, y equals 2 sine of x. Well, y equals a f of x stretches the graph vertically with a scale factor of a. So 2 sine x will stretch sine x vertically with a scale factor of 2. So it'll stretch up to 2 and down to minus 2. These crossing points on the x-axis will stay exactly the same. The 5th question, y equals the sine of 2x. Well, f of ax stretches the graph horizontally with a scale factor of 1 divided by a. So sine 2x will stretch the graph of sine x horizontally with a scale factor of 1/2. So everything's going to shrink in by 1/2, and you would get something like that. Number 6, y equals minus sine of x. Well, minus sine of x is a reflection in the x-axis. So the same will be the case for minus sine x. That means it's going to reflect vertically, upwards and downwards. This bit will reflect down, this bit will reflect up, and so on and so on. And then lastly, number 7, y equals the sine of minus x. Well, f of minus x reflects the graph in the y-axis. So it's going to reflect left and right. The y-axis will act like a mirror. And you'll get something like that. Okay, example 2. For x in the range 0 to 360, sketch the graph of y equals 2 times by the cosine of x minus 30 degrees. Now you really need to build these up like we did in the last example. So first of all, you sketch cos x between 0 and 360, then cos x minus 30, and then last of all, 2 cos x minus 30. So you really need to do 3 sketches to get to the answer. I'll let you have a go at this, pause the video, and come back to me again when you're ready. Okay, let's have a look. So first of all, we'll sketch cos x between 0 and 360. It would look something like that. Then we'll sketch cos x minus 30, which means it's going to move to the right by 30 degrees. So the whole graph would shift right by 30. Then we'll do 2 cos x minus 30, which means vertically it's going to stretch with a scale factor of 2, so it'll become twice as big in the vertical direction, and it'll go up as far as 2, down as low as minus 2. But those crossing points in the last graph, those won't change at 120 and 300. So that would be the answer. Example 3. Between 0 and 360, sketch the graph of minus the tangent of x plus 45 degrees. Again, 3 steps. First of all, sketch tan x, then do tan x plus 45, and then do minus tan x plus 45. So you need to do 3 graphs. Pause the video, have a go, come back to me when you're ready. Okay, let's have a look. So first of all, you need to sketch tan x between 0 and 360, which will look something like that. Then you need to do tan x plus 45, which means it's going to move left by 45 degrees. So it'll move back here. Then you need to do the reflection minus tan x plus 45, which is a reflection in the x-axis. So it'll reflect down for this part here and oscillating for these 2 bits. That would be the answer. Okay, that gets us to the end of the lesson. If you've got the textbook, then turn to page 128 and have a go at exercise 6G. Thank you very much for listening, and cheerio.